Hello everyone, welcome to the No-Till Training Program's 8-part webinar series. This training has been developed through a collaboration between the University of Vermont, University of Maine, and USDA Natural Resource Conservation Service. All associated work and materials are supported by the National Institute of Food and Agriculture, U.S. Department of Agriculture, through the Northeast Sustainable Agriculture Research and Education Program under subaward ENE 18-149. This webinar will focus on precision agriculture technology and no-till with a presentation by Scott Magnan. Scott Magnan is a St. Albans native, owning a custom cropping operation. He runs his own farm, converted to no-till in 2011, producing primarily soybeans, hay, corn, and sunflowers. Scott also owns a shop in St. Albans specializing in precision ag technology as an ag leader dealer.
Good morning, everyone. So I'm here to, as Catherine mentioned, talk about precision ag technology for no-till. So my presentation is more than just talking about precision ag and no-till. I wanted to use experience of things that we have done in Vermont. So I included all the coverage maps in the presentation are from technology we're currently utilizing or trialing in this state. The majority of the field shots were also taken in Vermont, and a few slides towards the end of the presentation are things now available to Vermont farmers that could be increasingly utilized soon. So we've come a long ways in the last 4 to 5 years. So now we can take things in state and present them, where before we were pulling information from other states to present to Vermonters. So kind of at the heart of precision ag is a display that's located inside the tractor. That display is generally connected to implements behind the tractor, and it's gathering information inputs from planters, fertilizing applicators, manure spreaders, inputting the data into the computer, and the data can kick back control information to apply rates that the operator selects. So it's constant input output on the field display, and while it's getting those inputs, it's mapping different attributes coming into the computer, and we'll get more into that through the presentation, which is just kind of an overview of what that does. So one of the other inputs is from a GPS receiver, and the receiver is what gives that computer the information to know what location it's at in the field. And there's different accuracy levels that operates at. WAS is a free service. It's not overly accurate, but it's very good for mapping, say, manure spreading records. As you move up into more precise practices such as tiling or corn planting, you're going to want either a prescription service, in particularly for planting. And if you're going to get into tiling, you would want an RTK system. So subscription service gives you more access to more satellites, so the triangulation calculations are more accurate with more satellites. In RTK, you're actually going to have a fixed point. You're going to buy a second receiver, put it in a location, mark the location, and you'll bounce your signal off that tower to give you sub-inch accuracy. One of the first things Vermont no-tillers have found useful is a steering system that uses that GPS information to help steer the tractor. So the operator will set an AB line on the pattern he wants. a very common one is an A-B line. So you'll mark an A point, mark a B point, and then you'll have repeatability on that line throughout that field. And the tractor will take control to stay on those lines. So here's a picture of a kind of a very common no-till field without steering, where these two lines, your orphan rows, kind of merge together. They can be farther apart. And the reason that's a little more common in no-till is because you have crop residue, either a sod establishment, a heavy cover crop, even residue from last year's crop. Where in a tilled situation, you till everything up and your row markers make a very apparent line, so you can stay on your row much easier in a tillage situation than no-till. So a lot of Vermont farmers have adapted steering systems into their no-till operation for this reason right here, or at least that's one other reason we're going to talk about more. So here's some of that map data. This was a farmer that called me late at night, maybe around 11 o'clock, very frustrated. He had a long day. He was probably on 14 hours of planting. It's dark out. It's a sod field, heavy clay. The row markers were completely useless. He's trying to steer the tractor with his GPS display with no steering. So he's got a lot of wavering lines here, some open sections of the field. There's probably some overlap as well. And you can these dark lines and the dark red versus the light yellow would be speed variation. So he's increasing and he's decreasing his speed, probably trying to find where that last row was. So his productivity at this point is down. And anytime you increase or decrease speed, you're also affecting your planter performance to some degree. So here's a speed map with steering. You can see a nice straight A-B line, less variation in speed. One area, the operator may have taken control of the steering system in this area. Perhaps there was a mud hole he had to go around, so slowed down the tractor, took manual control, kicked back into a steering situation here. So a lot of benefits you can see in this map here to having a steering system in a no-till situation. Both fields were very similar in soil type, and in they're both sod situations. So the benefits of a steering system would be less fatigue. We talked about that operator late at night. He had worked all day. Had he had a steering system, a little less fatigue, and he could have kept going and had a nice field at the end of the day. Reduced underlap or overlap, more consistent ground speed, more time to focus on the implement. So you're not steering the tractor, so you can look back within some degree at least to see what's happening with your implement, see how your row units are looking as they cross the field. Maybe you'll notice and hear a noise a little bit better, so more time to focus on what's happening. You have repeatability to perform other field operations with minimal crop losses, which we'll talk a lot about later. Steering systems do not typically turn on headlands, so you gain manual control at the end of that straight line or that whatever your pattern is, and you turn back on, hit a button, and it reacquires the line. It doesn't know where rocks are, so you still need to be alert, and you need to steer around those areas, much like that operator did in the map you saw where he went around the mud hole. It doesn't slow up or speed up the tractor, so if it's a little bit bumpy, you still have to slow that down. It's not going to do that for you. I suppose that could change in the future moving forward, but currently that's where we're at. So the operator still maintains full function of these aspects of the operation, that being these down here. So another place we tackle in Vermont farms is planting. It's becoming increasingly common for farmers to adapt precision ag practices on their planting systems. Probably the first one that a lot of farmers had, and we're one of them, was advanced seed tube monitoring. So the older monitors gave you a light indicating whether you were planting seed or not planting seed. And we didn't have any information that would tell us what was actually going on with the planter, except for that it was planting or not. So new monitors give us a lot of information. So we have access to population. So if we set it at 32,000, we're planting at 32,000. And if it jumps a chain sprocket and goes up to 34, we have that information. We know what happened in real time. We can look at singulation. That is looking at skips and doubles here, and giving a percentage of how evenly that planter is planting. So with skips and doubles, we look at skips at 2.6, our doubles at 1.4. Those are generally pretty good numbers. We want to try and make these as even as possible with, say, an air pressure adjustment on a vacuum planter. So if we have more skips than doubles, we could add a little bit of air pressure. So we have that information in real time to make adjustments on the planter to increase performance. We can look at that row by row if we suspect one row isn't performing as well as another. This is an example of a 12-row planter. We look at row 10. That may be the one that's affecting our singulation. So we look at row 10. We can go out, see if maybe there's a loose gasket, a broken parallel arm, or something affecting that row 10, and make an adjustment, and that would increase our overall singulation. Then we get data out of that planning operation that we can look at later. In this field, I have a doubles map up. We got a legend over here. So very few doubles in the red, a high number of doubles in the green. So we went from a little more red and yellows into more green. So there was something that happened there. Did the planter decrease performance, or was there something in the field that affected that map? In this case, I know what it was. This is very loamy soil up here, very rocky down here. So the planter started bouncing more in this area, dropped more seed than desired down in here. So this was an issue of a field preparation. So it's something that the farmer could look at in the winter and make a decision to improve for the next season. All right, we're gonna move into down pressure. So first, before we talk much about how precision ag affects down pressure, we need to know a little bit about the function of our row unit. So we have weight being applied down on our gauge wheel. This is a gauge wheel. It's important to know what that part of the planter is. So everything's being applied down onto this gauge wheel from up here. So seed box weight, row unit weight, and our toolbar weight has an effect on the row unit. And then you have upward pressure, soil resistance. So tight soils are going to push up on the opening discs here. They're going to push up on the closing wheels, up on the gauge wheels. If you had an opening disc or row cleaners, you would add more up pressure. So the more things touching the ground, the more up pressure we have. And the more weight we have here, the more down pressure. So we need a way to control that or add that so we can achieve some even depth across the field without over applying pressure on the gauge wheel. So we have different ways to apply down pressure. In precision ag, we're going to use hydraulic down pressure or pneumatic down pressure. A hydraulic system applies downforce to the row unit within a second. So going back, we have a gauge here on our gauge wheel that has a reading. And if that reading changes, it's going to change this within a second. On an air system, it's going to take several feet to adjust. So it's going to have to pump air into the bag, let air out of the bag. On all of your older planters, stock, they came with springs. This is a heavy duty set of springs, so maybe it was an older planter adapted for no-till, and they wanted to increase that down pressure on the gauge wheel, so they applied heavy springs. So we're looking at a tilled field with gauge wheel pressure. So we're measuring the amount of pressure on that gauge wheel. So you can see it's a lot of yellows, a lot of greens. So we're in the range of, I would say, 100 upwards to 150 pounds in a tilled field. We're in that same field. This is the amount of down pressure applied. So we have a lot in this area. This is a very low legend. We're basically under 10 pounds of down pressure being applied. This planter had hydraulic downforce. So we were able to control that downforce. So basically in this tilled situation, we had no hydraulic pressure in that system. It was just the weight of the seed boxes being applied down on the planter, and we had adequate downforce to have an even seed bed. Going backwards, you can see the evenness of this field, and that's ideal. We want to see a nice even seed bed with the minimal amount of downforce. We want to be generally in the range of 50 to 150, but it's going to vary depending on the field a little bit and the conditions. If it's a little wetter, I'd like to have a little bit less. If it's a little more compact, we want to be on the safe side and have a little bit more. So I think the tilled field is a very good example of what we're trying to accomplish in a field. It may not be what we're trying to accomplish overall with our farm, but as far as down pressure goes, it's a good reference. So we've got a no-till into sod, measuring the gauge wheel pressure. So you can see very low pressure in this area here. We have low pressure, high amount of pressure in the blues. Over here we've got a field that was a little more even, kind of in this 100 or even in the 30 to 100 to 150 range. So pretty ideal there. A lot of variability here. All right, this is the downforce applied. So what do we see here? And I'll just have you look at it. We're going to talk about it in the next slide, but you can make some observations on this field and this field. So this is what we're adding or subtracting from pressure applied on that row unit. All right, so here are some of those things. Planted field road, maybe you can find out where that is. If not, it's right there. Boom. A lot of wheel traffic on this road. So we applied a lot of force to get seed in the ground there. And in some areas, I don't think we even got seed. Right here, the planter wasn't even able to go in the ground. It just lifted out of the ground. Potential soft spot here. So we had almost no pressure applied. It was just the weight of the boxes. Something there was soft. We don't know what. Looking at the map, we can just make some assumptions. Variability in the seed bed, a lot of different color variants. There's a ledge right in here. It applied a heavy amount of downforce to try and get through rock. The operator may have moved to a heavier setting, so he may have checked his seed depth over here in the blue, had to bump his setting up, which we're going to talk about a little bit in the presentation coming up. So what we have here is a compaction map. So I see a lot of compaction issues over here in this field. And in this field, it looks pretty good. This was probably either a sandier soil or a reduced tillage situation. We can go to a doubles map here in our legend to further identify issues. So we talked about in that earlier field, we're trying to further troubleshoot what's happening in this field. So we have a lot of green over here, 7% to 16% doubles in the green. Probably indicates a rough situation. The planter was bouncing. Remember, we had some ledge here, so there's probably some rocks in that surrounding area. If you notice here, very few doubles over here in that field that had very even down pressure applied. So fewer doubles in that field. So we've got some issues here. We've got an issue here and something to look at here. So maybe in that field, the operator called the tech service, hey, my planter is not working very well. What's going on with my planter? So we might want to give them a chart like this to troubleshoot with. Consider the two categorical influencers for applied force, the row unit and field conditions. Typically, the row unit will be unchanging throughout a planting season, whereas field conditions change seasonally and spatially. So we can look and see if that was a planter issue. If someone called me and said, hey, this is happening. So we'll talk. First, I might ask if he has enough weight on the planter. If he had central fill or row hoppers. Central fill, he might be a little bit light. Maybe you could fill his seed boxes up, add more weight. If he's kind of maxed out on his down pressure system, especially if that was a spring system, we want to get more weight on. Soil engaging components. How many components on the planter are there for the ground to increase the up pressure on? So maybe he's got opening discs, a set of row cleaners. Maybe his row cleaners are fixed, meaning they're not floating, so they're applying excessive up force on the planter, pulling it out of the ground, especially if they're not adjusted correctly. So we may need to check the adjustment on the planter. Speed, how fast are you going? So if you increase your speed, you're going to increase the amount of resistance going up on the planter. So you may need to decrease your speed to get the seed in the ground. Depth setting, that's usually a fixed position. So you would try and get your seed depth adjusted correctly in a part of the field where downforce was being applied correctly. Clothing system, we could look at that. Maybe not really in relation to downforce, but if not enough was being applied to that closing system, it might not be closing. You may need to increase your spring pressure on the back, or perhaps you have a different system like an air system. Wear items, I could see where that might add resistance to the planter. If, say, your opening discs were not adjusted properly or wore out, you might not be able to get proper seed depth, and it might actually be adding some resistance to the planter. So let's say everything there was pretty good. We would start to look at field conditions, some field conditions that could affect the upward force or just planter performance in general. Cloddiness, maybe a poor tillage job, or maybe you're no-tilling into a pasture. Crop residue, heavy residue from last year's crop is causing the planter to ride up on, say, some old corn stalks. So we could either apply more downforce, or maybe we need a set of row cleaners. Soil moisture, if it's very damp soil, we won't need much downforce. If it's heavy clay that's in a dry season, we're going to need more down pressure. Soil type, very similar to moisture. The loamier the soil, the less down pressure, and the heavier the soil, the more down pressure. tillage pattern, I could see where you would just want to ride with the last tillage pass if possible if you were using tillage. Otherwise, you're going to have like an increased set of doubles. Tillage system, very similar to tillage pattern. Either in any tillage system, you want to try and have fairly even down pressure and reduce skips and doubles. So this is kind of about how to set up your hydraulic downforce or even your spring setup to know if you have a good spring setup, not a good spring setup. So first you want to consult with a trusted agronomic advisor to gain an understanding of the impact of seed depth and sidewall compaction to the crop being planted. So your end goal is to have even seed depth. If you increase your sidewall compaction with too much downforce, you're going to have issues with your crop growing. So you're going to have compacted sidewalls. So you need to understand how applying too much downforce can have a negative impact. And I think we'll talk more about that down here. So set target depth and begin planting on an intermediate setting. There's different settings on your down pressure system generally. The objective is to achieve and maintain target seed depth at all times without inhibiting root development from overcompaction of the seed trench. Important, proper force is between the extremes of inadequate force resulting in depth loss or excess force resulting in compaction. Check for depth loss in areas of the field with the lowest and highest values of applied force. If depth is being routinely lost, consider moving to a higher setting. If compaction is being routinely observed, consider moving to a lower setting. So in the case of our earlier field, he may have checked his depth in one of the higher compacted areas and moved to a higher setting, resulting in a little more blue in that screen, which was a good call because you probably want to be on the high side rather than the low side. Seed in the ground's better than seed not in the ground, even if you have a little excessive force. Utilizing the information, what actions are needed? Planter downforce setup can improve stand counts in this situation. So just like I said, he increased the downforce to make sure the seed was going in the ground. Precision Ag downforce data helps identify this field as likely having soil variability that needs action beyond planter setup for maximum yield gain. So he adjusted the planter, but it didn't fix the field. Poor soil health plus poor planter performance setup equals lost revenue. Down pressure sensor data would have identified increased up pressure on the row unit from the floating row cleaners. So this was a planning job that I did. I don't know if I should take credit for it. I shouldn't, but I am. So I went in, I planted, I was tired, I'm trying to run a business, and I set my planter depth probably in an area of the field that was fairly good. I had my row cleaners down going into a sod situation, and my belief is the sod added a little upward force on my row unit, creating a situation where my planter was riding up and down and my seed depth wasn't even. And we ended up with a very dry summer. So any planting error was a big error because my field wasn't able to recover. So this ended up being an unharvested field. So we lost 10 acres of potential revenue because soil health wasn't great. It couldn't overcome poor planter performance. So it was kind of both cases weren't good, and this is where no-till fails happen, and this is where Precision Ag could have helped avoid that fail. When soil health and planter setup are addressed, you get positive results. And this is just an example of a very healthy looking crop in which everything was functioning great. Soil health and planter setup were both set up very well. Taking action with precision. What needs to be addressed? What tool do we need for the job? All right, we're moving into some other areas now. So weed control. Liquid application tools provide exact rate control and automatic shutoff of product. Steering control for application of products, as well as improved efficiency and accuracy when using cultivation tools. So here's a liquid application of herbicide, very common in no-till. Liquid application receives flow rates from a flow meter signal and then applies a target rate that is generally controlled by pump speed. Shutoffs are in place so the sprayer shuts off automatically anytime the boom overlaps, minimizing overuse of chemicals. Rates match the label on the herbicide product, so we're able to look at the rates on the product, set in the actual target rate, and apply that amount to every part of the field. And there's different tools that are used to control the shutoffs, which we'll allude to a little bit later when we in another slide for a different application. In this photo, a steering system is used while planting and again when cultivating, using a flat cultivation point for minimal soil disturbance and weed control. So here we planted with a steering system. This was a subscription service, so we had pretty good accuracy row to row, and we were able to go back in with a cultivator and do a reduced tillage pass using this cultivator, and you can see we still have a lot of crop residue. We're able to slice the roots off at the base of the weed, which in this case was grass, and we left our crop standing without damage. So Precision Ag gave us another alternative to spraying, and I have a short little video of that being done with that cultivator. Whoops. All right, so our speed was pretty good. We were pretty efficient cultivating using a steering system, and accuracy was desirable. All right, and our last presenter talked about some limitations on subsurface fertility in a no-till situation, and it's probably very true in a 100% no-till situation. So I know another presentation talked about no-till, and then there's Vermont no-till. So we have some tools that we can address subsurface fertility with after we've established our field in no-till, if we find that we need to address that. One of them is a manure injector, which was also mentioned in the last presentation. And Precision Ag adds to that in that we can control and monitor how much manure that we're putting down through that injection tool. And I have a little video showing us going very slow. So manure injector, this one has discs on it, and if you increase your speed, you increase your soil disturbance. So we applied our flow meter on there so we can go a little bit slower while applying less of a rate. Otherwise, that's harder to control, and the video kind of shows that. All right, once we've applied the applied the manure, we have some information where we can pull reports, look at data, and this fairly even application rate here of in the 3,000 to 4,000 gallon range. And we'll end up with a field average of that. I believe that one's like 3,700. That was a grass applied field. And we'll also have some quick, accurate record keeping, which will increase our efficiency when filing reports. It can enhance funding opportunities for your no-till operation, having readily available information. You'll get those reports out quicker, and you'll could add a little bit of professionalism to your business as well. Provides a tool for sound decision making. So you have all those records. You can plan a little bit faster and be a little more efficient in your planning. Cover cropping is another tool that has been talked a lot about in other presentations. Pictures an interseeder that could be enhanced with a steering system and seed tube monitoring. The same principles would apply to a grain drill or even broadcasting. So steering system increases our accuracy row to row. Same as the cultivating, you could increase productivity in this operation. If you had a way to monitor your seed, I haven't done a setup on a grain drill, but I believe it's possible to at least know if you're dropping seed, not dropping seed. Be very helpful. Same with broadcasting. If you're gonna do with like say a 40-foot spread pattern, broadcasting, you're not even gonna be able to see where your seed is by the eye, so a steering system would greatly add to a broadcasting cover cropping method. We did a setup on an air seeder. This was a system that had a lot of helpful components. We did a steering system with automatic shut off, so we could shut the unit off. The unit would shut itself off when there was overlap. We're going to talk more about it. So in this one, we had seed dropping down onto a conveyor, went into a fan, blew seed out evenly across the row or across the implement. A little technical knowledge on how these systems work for those of you that are interested. So an encoder counts the rotation of the shaft in order to adjust the amount of hydraulic fluid regulated through a servo valve to turn a hydraulic motor at the speed needed to drive the bed chain or belt delivering product through the gate onto this one has rotating spinners. It's a granular fertilizer spreader. You could also use it for seeding. In the case of the air seeder, we put that product into a fan system under very similar with similar components. So here's our air seeder map. Even coverage with the ability to set a rate. So you set a target rate, was able to apply that rate with steering and with swath control and steering, he kept that rate even. All the yellow is a very even rate. There is some little marks, red marks, which I believe are where it shut off or turned on. Maybe we could make some adjustments with that. I think there was an outside pass here. Maybe it wasn't working correctly, so we had to replant. But even the replant with those functions, he was able to go back and do that. So overall, a very effective tool for cover cropping, and it would be hard to mimic this without precision ag. Another tool Precision Ag can offer is for strip till operations and cultivating. Also addressing the subsurface fertility with these tools at the same time could be very helpful. So by adding fertilizer application tools during these practices, we address subsurface fertility, weed control, and compaction in one operation. We need good pass accuracy. A subscription service will be needed. RTK is recommended. Recorded and labeled guidance lines will help track nutrient placement for future reference and planting. Maybe you want to come back in the spring and plant on these rows. With precision ag and steering, you have the ability to do that. Especially if you placed fertilizer down in these rows, you'd want to be planting on them and not off by 3 inches. We could do the same thing with our cultivator. When we did our no-till cultivating, if we wanted to add product at that time, we could. Here's the strip till fertilizer application map. So he applied his product in the fall. We have a record of that fertilizer application that he can reference later. He also knows where he ended. Maybe he remembered putting down product in this field, ran out of fertilizer here, and kept strip tilling. Well, now he's got a reference of where he needs to apply fertilizer in the spring. He could pull this map up and apply a spring application of fertilizer where he ran out. So the mapping is very helpful. And having that control on the strip tiller, same as the cover cropping operation, our product was even across the field. This is one of those slides that we haven't seen a lot about, seen them much in Vermont yet, but the technology is here. Crop sensors bounce light off a crop and measure the reflective properties of the crop. Algorithms are developed using the data to reference crop health and determine the nutrient needs of the crop on the go. Nitrogen is currently the only nutrient we have algorithms for, to my knowledge. So it's a way to put down variable rate fertilizer on the go. So in our earlier slide with the field, we've talked a lot about, we had a spot where we didn't need much down pressure at all. My assumption is there's probably a wet hole in there, so we might need to address that with drainage tile. So precision ag can help our tiling operation. A tile plow uses an RTK signal to control the tile, plow vertically, and a signal to run a straight line horizontally, providing a service for modern day tiling systems. So we could use precision ag to work on our fields in those areas needing work. Harvest, yield data. It's very common on combines and found locally on some choppers. Yield monitoring is a very important piece in fully utilizing all the precision tools on your farm. With that data, we gain the ability to identify gains and drops in yield. From there, field improvements can be made, equipment issues identified, and plans can be made to utilize inputs as efficiently as possible. So in Vermont, we have a lot of tools at our disposal. Yield monitoring is up and coming, and it's certainly a key component to moving forward. So we have all this data. This is just a very general I guess there's a lot of ways to move data. We can do it through wirelessly, through a USB, move data from the monitor and the tractor to our iPad, to our office, look at that data, send it to advisors. It's very much, precision ag is very much in the up and coming computer world. Things that we deal with quite often it's not absent from precision ag. And a lot of different companies have a lot of different ways to do this. So moving that data, now we have the ability to do some prescription writing. Prescription writing is a mapped predetermined rates for seeding, fertilizing, and manure application using a software program. Based the prescription on a variety of map layers and previously recorded data. So we take all that data, send it to an advisor, and it comes back as a prescription for whatever product that we want to apply. It could be seed, fertilizing, manure, and that map might look something like this. So there's areas of high, or maybe this is high, low, and our average. Punch that back into our field computer to apply the correct amount of product. So we might look at something like this in the cab. So we'd have automatic control through these areas here. Really through the whole map would be automatically controlled. We're gaining increasingly easy access to being able to do this. The number of advisors is growing, and the amount of people that have access to getting those prescriptions to an agronomist back to the farmer, and the speed that it's done is growing. Our company just came out with a way to send the maps to our agronomy team and have it kicked back in a very short amount of time. So you could be pulling off a harvest one day and applying product to get ready for the next season using variable rate the following day.